Today we're going to be doing 7.3, Day 2, Multiple Step Factoring. So let's write down the guidelines. So number 1, common factor. You will use common factor when you have 2 or more terms. So let's write that down, 2 or more terms. And you will always do this first. No matter what problem you're doing, you will always do this first. Okay, and as we talked about this in class, this is known as greatest common factor, GCF. So it's best to find the greatest common factor, so you just have to do it once. The next one is 2 terms. If you have 2 terms, you will do difference of squares. Difference of squares. If you have 3 terms, you will do trial and error. If you look up how to do trial and error, maybe online or different things, you might even see it called guess and check. It's the same thing, guess and check. And lastly, for 4 terms, we will learn this more in the next lesson, but to do 4 terms, you would do what's called grouping. And again, we won't cover that in this lesson, but it is another factoring term that we will be learning eventually. So let's go ahead and go to number 1. Notice how it says factor completely. Factor completely means you might have to do multiple factoring methods to get this completely factored. Okay, so normally we just use one, but now we might have to use multiple. So let's try this. So factor completely, remember the first factoring method we always use is greatest common factor. So do we have a greatest common factor here? Well, we have 10, 25, and 15. 10, 25, and 15. We know that 5 can go into all of those, so let's factor out a 5. And now we are left with 2x squared minus 5x plus 3 on the inside. Again, how did we get that? Well, 5 times 2 is 10, and then we bring down that x squared. 5 times 5 is 25. Bring down that x. 5 times 3 is 15. Now, are we done factoring? No, we have 3 terms left right here. And if you scroll up a little bit, you can see that if we have 3 terms, we will use trial and error. So let's use trial and error here. So trial and error, I usually write T and E. So remember to bring down that 5. And trial and error involves 2 parentheses. We're going to look for what sign we're going to use. Since that's a positive, we're going to use the same sign as before it. So that's a minus, so therefore we need a minus in both parentheses. Then we're going to get our factors of 2, which is this 2 right there. So we have 1 and 2, which is pretty easy, x and 2x. And we need our factors of 3, which is 1 and 3. So let's go ahead and put in our 1 and 3. And we can go ahead and check and see, are we correct? That's the nice thing about this, is we can check it. So negative 1 times 2x is negative 2x. X times negative 3 is negative 3x. Add those together, we get negative 5x. So we are correct. So let's go ahead and highlight that. This is our correct answer. Okay, that didn't highlight very well, but let's just go ahead and box it so it stands out. All right, number 2. Remember, the factoring method we always check with first is greatest common factor. Do we have a greatest common factor between this 50 and 32? And the answer is yes, it is a 2. We can bring out a 2. So what are we left with? Well, 2 times 25 is 50. Bring down that x squared, bring down that minus. 2 times 16 is 32. Now, are we done? Well, we have 2 terms and a minus sign. So if we have 2 terms and a minus sign, we will do 2 terms. And let's go ahead and put that right there. If we have 2 terms with the minus sign, that would be a difference of squares. So let's go ahead and do that. So we have difference of squares here. So DOS, bring down that 2. Now we have a difference of squares. Remember, it's like the square root of 25, a number times itself. That's 25. So we have 5x. And then we're going to use a plus. And let's do our second parentheses right now while we're at it. 5x minus. So we have, now we have 16. What's a number times itself? That's 16. Well, that would be 4. So we have our final answer here. We are done. Now remember, we can't do difference of squares here because we don't have an exponent of 2 up here like we did up here. That's the only reason we were able to, here, let's see if you could see it. There we go. So we had an exponent of 2. So that's the only reason we're able to do difference of squares here opposed to here. There's no exponent 2. So we are done here. Okay, let's go to number 3. Okay, we have this. The factoring method we always check with first is greatest common factor. So let's go ahead and check with greatest common factor first. Do we have a greatest common factor here between this 10x, 23x squared, and 12x? Well, 12, 23, and 10 do not have a greatest common factor, but we do see that each term has an x. So we can factor out an x. So let's take out an x, and now we are left with, okay, let me erase these little things right here. I don't know what these are. There we go. Okay, so now we are left with what in our parentheses? Well, we could bring down that 10. We're left with x squared plus 23x plus 12. Now we have 3 terms. So if you look at the top, if you have 3 terms, you will use what method? Trial and error. So let's put T and E. Trial and error. So let's bring down that x. Trial and error means we have 2 parentheses here. Now we're going to get factors of 10, which we know for factors of 10, we're going to use the factors closest together, which are 2 and 5. So let's do 2x and 5x. Then we have factors of 12, right? So 10 and 12. So 1 and 12, 2 and 6, 3 and 4. So just like we use the closest ones together on for 10, 2 and 5, we will use 3 and 4. So let's go ahead and put those in here. So notice I'm going to put the 3 over here. Can I put the 4 over here? I'm doing this on purpose, actually. Can we put the 4 with the 2? The answer is no, because those have a common factor of 2, because 2 can go into 2 and 2 can also go into 4. So what we're going to have to do is switch this 4 with that 3. So let's go ahead and switch those 4 with the 3. Okay, so let's put our 4. Oh, where did that come from? Let's get our red back. All right, here we go. So we're going to do our 4 with this 5 and our 3 over here. Now we can go ahead and check this. Are we correct? Well, 3 times 5x is 15x. 2x times 4 is 8x. Add those together, we get 23x. So yes, we know we are correct. So let's go ahead and box our answer. Okay, let's go to number 4. We always check with greatest common factor first. Factoring method first, greatest common factor. Do we have a greatest common factor here between 3, 3, and 18? And the answer is yes, that is a 3. Now let's look at x cubed, x squared, and x. What's common between those? Well, it has 1x. So let's factor out 3x. And what are we left with? Well, 3x, we're left with x squared. And then minus x. The minus 3 times 6 would give us 18. Now what factoring method can we use? We have 3 terms. 3 terms, if you look at the top, that is trial and error. So we have T and E. Let's bring down our 3x. 2 parentheses. What signs go in our parentheses? We have that minus, which means you're going to use both signs, just a plus and a minus. We have x squared, so we know we're going to have x. And then factors of 6. Well, let's go ahead. We have 1 and 6, 2 and 3. Let's use the factors closest together. So we'll use 2 and 3. We can go ahead and check this, make sure we are correct. 2x, 2 times x is 2x, and then negative 3x. That gives us negative x, so that checks out. We are done. Let's go ahead and move on to number 5 on the next page. Let's. Okay, what factoring method do we always start with first? GCF, greatest common factor. So do we have a greatest common factor here? We have 20 and 45. What number can go into 20 and 45? If you said 5, you are correct. And we can also see we have a greatest common factor with these x's. We have an x in both terms. So what do we have left here? Well, 5 times what is 20? That's 4. We have 1 x on the outside, so that leaves 2 on the inside. Bring down that minus. 5 times 9 is 45, and we have that x. Are we done factoring, or can we factor some more? The answer is we aren't done. We can factor some more, and we have difference of squares. We have 2 terms right there, so that is difference of squares. So let's bring that 5x down. We can't forget it. Back. Okay, here we go. Let's go ahead and put our 2 sets of parentheses. And difference of squares, we know we're going to have a plus and a minus. And let's go ahead and get our factors of 4. Well, we have a number times itself, that's 4x, or that's 4 is 2. So we have 2, and we're going to put our x in there. Now factors of 9 that are the same, that multiply to 9. So 2 factors that are the same number, which would be 3. 3 times 3 is 9. And we are done. Let's go to number 6. Okay, what factoring method do we always check with first? Greatest common factor. Now let's see what the greatest common factor is between 36, 18, and 4. Well, a number that can go into 4, 18, and 36 would be 2. And do we have any other greatest common factors here? Well, I see they all have an x, so let's go ahead and bring out an x as well. That's another greatest common factor. So 2 times what is 36? 18. We already have 1x out here, so that leaves 2 inside. Bring down that plus sign. 2 times what is 18? 9. We have 1x out here, but we have 2 right here. So that leaves 1 down here. Bring down that minus. 2 times what is 4? That would be 2. Okay, we have 3 terms left. When we have 3 terms left, what factoring method can we use? If you said trial and error, you are correct. So let's use trial and error. Don't forget to bring down that 2x. Trial and error means 2 parentheses. What signs? Well, we have this minus, which means we're going to use a plus and a minus. All right, now let's get factors of 18 that are closest together. So we have 1 and 18, 2 and 9, 3 and 6. So 3 and 6 are closest together. Let's put those in there. Now our factors of 2. Oh, those are nice and easy, 1 and 2. So remember, 2 cannot go with the 6 because 2 can go into 2 and 2 can go into 6. So we can't put 2 here, but we could put 2 over here. So let's put 2 with that 3. And we could put our 1 right here. All right. Now, can we check this? Of course you can check it. See if you're right. That is 2 times 6x is 12x. 3x times negative 1 is negative 3x. Add those together, we get 9x. So that checks out. We know we are correct. It's always good to check it. If you're trying to get a good grade, you want to check, make sure you did it right. Okay, let's look at number 7. What factoring method do we always check with first? GCF, greatest common factor. Now let's look right here. Do we have a greatest common factor between 8, 17, and 2? Nope. What about x? Do all of these terms have an x? And the answer is no. Therefore, do we have a greatest common factor? No, we don't. But we still need to check, right? Because we might, but we don't in this one. That's okay. Let's go to the next part. Now we have 3 terms. What factoring method can we use with 3 terms? Trial and error, T and D. So let's do our two parentheses. And what signs are we going to use? Well, we have that plus, so we're going to use whatever is in front of that. So minus goes in both. And let's go ahead and get our factors of 8. We have 1 and 8, 2 and 4. And then we have factors of 1 and 2. Now let's just stop and look at these factors, because normally we would circle 2 and 4 and 1 and 2. But if we look at 2 and 4, and we look at 1 and 2, can 4 go with that 2? Nope, because they're the same. So we'd have to switch and put 2 with that 2. Can that 2 go with that 2? Nope, because they would have the same common factor. So therefore, we can't use 2 and 4, but we can definitely use 1 and 8. So let's put everything in here. So we have 1x, 8x. Then we have our 1 and 2. So our 2 cannot go with this 8, because 2 goes into 2, 2 goes into 8. So let's put our 2 with that x, and our 1 with that 8x. And we are done with this one. And again, go ahead, it's always a good idea to check just to make sure you're right. So negative 16x, negative x, and yes, those add up. So we know we're correct. Okay, let's go ahead and head to number 8. What factoring method do we always check with first? Greatest common factor. Do we have a greatest common factor between this 100 and 100? Yep, you are correct. It is 100. Hopefully that's what you said. All right, so we have 100 times what is x squared? Well, we just bring down that x squared, bring down that minus, and 100 times 1 is 100. Now we have two terms with an x squared. So what do we do next? We do difference of squares, DOS. So let's bring down that 100. Two parentheses, and difference of squares, we know we have a plus and a minus. Let's separate those x's, and the number times itself, that is 1, would be 1. And that is our final answer. Let's go to number 9. What factoring method do we always check with first? Yep, we check with greatest common factor. So GCF. What is our GCF here? Let's see. I have, let's see here. We have 6, 9, and 60. A number that goes into 6, 9, and 60. If you said 3, you are correct. And do we have any other greatest common factors? Well, we can see they all have a y, so let's bring out one y. And what are we left with in parentheses? Well, 3 times 2 is 6. Bring down that x squared, and we already have our y out here. Then we have our plus. 3 times 3 is 9. Bring down that x. Bring down that minus. 3 times what is 60? That is 20. Now we have 3 terms left in parentheses. So what factoring method do we do next? We do 3 terms, means trial and error. So let's bring down our 3y. Trial and error means 2 parentheses. We have 2x, which means we will have 2x and x. We have this minus, which means we'll have a plus and a minus. Here, let's do this, a minus and a plus. And then we have our factors of 20. What would those be? So let's do our factors of 20, 1 and 20, 2 and 10, and 4 and 5. Let's use 4 and 5 since they're closest together. That 4 cannot go with the 2, so we have to put it with that x, and we put 5 over here. Let's check and see if we are correct. Negative 5x plus 8x. That gives us 3x. So yes, we are correct. Let's go ahead and go to number 10. Let's erase this. Now let's go to number 10. What factoring method do we always check with first? Greatest common factor. So what is the greatest common factor between this 64 and 81? Do we have a greatest common factor? Actually, our answer is no, we don't have one. There is not a number that can go into both 64 and 81 besides 1, but we can't pull out 1 as a factor. So let's go ahead and go to the next one. We have two terms and we have this square right here. So what do we have? Difference of squares. So let's go ahead and do DOS. Difference of squares means two parentheses, a plus and a minus. And we have 64. Square root of 64, well, we have 8 times 8, definitely. So 8x and 8x. A number times itself, that is 81, which is 9. And we are done.